Hello and welcome to this Price of Job tutorial. In this video, we'll take a look at the Beam Connections module. To access the Beam Connections module, navigate to the module toolbar and select the Structural Members category, and then select Padstones and Connections. From the submenu, select Connections, and create the module. And to get started, we'll input the number of connections required. Price of Job supports a number of various beam connections, including an end plate, a fin connection, a splice connection, a beam-to-beam connection, cleats, or a base plate. Let's start with an end plate connection. An end plate connection involves welding a plate to the end of the beam, drilling holes in the plate, and then securing it with fixings. From the drop-down menu, we can select the metal plate that we choose to use. Then from the fixings, the quantity is automatically calculated for us. We'll require 4 fixings for one connection. If we increase our connections, the total fixings are increased to 8 fixings, with each end plate requiring 4 fixings. Then from the drop-down menu, we can select the bolt length and diameter size that we prefer to use. If we require additional bolts, we can simply click the icon here to increase the number. Next, let's take a look at a fin connection. A fin connection is when one beam crosses another. A plate is welded to the main beam and then bolted to the supported beam. Again, for this, we can set the number of connections required and then choose the plate size that we need to use. Then we can select the number of fixings needed and choose the bolt size and diameter. Next, we'll take a look at the splice connection. Splice connections are often used for loft conversions when the weight of the beam is too heavy to lift up to the loft, or the beams are too long to navigate through doorways, or other similar scenarios. So rather than hiring a crane to hoist the beam into place, the beam is cut to size and then reattached in place using splice connections, which involves bolting plates to both the top and the bottom flanges, as well as both sides. So in this splice connection, we would have 4 plates, top, bottom, left, and right. Here in the connection stage, we can select the web section plates, so this would be for the left and right, and we can select the plate size. And then for the flange section, this would be the top and bottom, again we can select the plate size. Price of Job has automatically calculated that we'll require 24 fixings for each splice. So if we were to increase the number of splices, the total number of fixings would automatically increase as well. And then we can use the drop-down menu to select the bolt size and diameter. Next, we'll take a look at the beam-to-beam connection. Beam-to-beam connections are typically used for a cavity wall or a solid wall and requires 2 members. Your structural engineer will specify how often they should be fixed and the spacing of the centers. Basically, holes are drilled through the beams with spacers placed in between. Here you can specify the beam length in meters, as well as the spacing. And notice the indicator arrows in the sketch pane to indicate the dimension of the spacing of the fixings. If we were to decrease our spacing width, say to 500 millimeters, we'll notice that our fixing stage automatically updates to increase the number of fixings required to 22. If we revert this back to a spacing of 750 millimeters, the fixings required are only 16. Then we can select the drop-down menu for the spacers to select the spacers that we wish to use. Next, we'll take a look at the fixing stage. With 8 fixings required for each connection, 2 connections will require 16 fixings. Then from the Materials drop-down menu, we can select the threaded bar that we prefer to use. And then we can input the single stud length in millimeters, currently set at 200. Next, we'll take a look at the cleat connection. A cleat connection is used when a cross beam is fixed to a support beam with cleats fixed on both sides. So in this sketch, we're only seeing one of the cleats. There is another cleat mounted on the other side of this beam. Here from the drop-down menu, we can select the size of our angled cleat, and under the fixing stage, we can select the number of fixings and size and diameter. Lastly, we'll take a look at a base plate. This base connection is usually a base of a column fixed to concrete. The base plate metal is welded to the column, and then bolted to pad stones depending on your structural specifications. Here under the drop-down menu, we can select the material for our base plate, and then we can specify the number of fixings required, as well as the size and diameter of our threaded bar. And here we can input our single stud length in millimeters. And PriceAJob automatically calculates all the materials and labor required. Now it should be noted for the labor that PriceAJob presumes that the threaded fixings have already been cast in concrete, that the only drilling required will be to drill the steel plate. However, if you need to drill and fix with anchor bolts, then you can simply add a new category for labor, and we could input a new line here to drill and install the anchor bolts with the expected time required. If at any point in any of the drop-down menus you're looking for a material that does not appear, you can select Edit Pack to search the PriceAJob library for a material under a different name, or simply add a new material by inputting the title, unit, price, category, and website link. As you make your various additions, PriceAJob automatically generates a nicely written description that describes the materials and labor required, and this is then transferred to your reports to show these descriptions in the quote to your customer. And that's how to use the Beam Connections module. Thank you for using PriceAJob.